These are the notes for section 5. Now, we've been learning about graphing and the different kinds of solutions and how many different solutions a quadratic formula can have. And now we're going to learn about something called the quadratic formula. And basically it's like a go-to for when all other factoring methods fail. Now, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we're looking at our book on our page 558, we can see that the equation is a formula that allows you to solve any quadratic equation that is written in standard form. Now remember, standard form is ax squared plus bx plus c. Now, it should equal 0 when we're starting to talk about equations. So, this is the quadratic formula. You're going to need to memorize this. And there's a couple of songs, if you go on YouTube or something and search it, there's a couple of songs that you can try to learn so that it's easier to memorize. It's really, we're going to use it often enough that it's going to become pretty easy to remember. So it breaks us down. See how it has this plus or minus? So it breaks it down into two different solutions. It has negative b plus the square root of b squared minus 4ac all over 2a, or negative b minus the square root of b squared minus 4ac over 2a. Let's go to the next page and try a few examples. Let's write the equation up here. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So let's go here first. Let's identify our different pieces. I have a equals 1, b equals negative 12, and c equals negative 20. Okay, let's go ahead and actually make this plus 20. Let's make it plus 20. So we're going to make it a positive 20. Okay, so let's start. We have negative b. b is negative 12, so I actually get a positive 12 plus or minus the square root b squared, negative 12 times negative 12 is 144, minus 4 times a times c, which is 20, all over 2 times 1. Then we start solving these things, and we're going to say x equals 12 plus or minus 144 minus 80 over 2. Now 144 minus 80 gives me 64. So I get x equals 12 plus or minus the square root of 64 all over 2. So I get x equals 12 plus 8 over 2, or x equals 12 minus 8 over 2. 12 plus 8 over 2 gives me 20 divided by 2, which is 10. 12 minus 8 is 4 divided by 2 gives me 2. So my two possible solutions are 10 and 2. Now it seems like a lot of work, but actually it's really nice because if you ever factor something and you're not sure if your solutions are correct, you can just quick throw it into this equation and you'll find out. So let's try this one. First I have equals 18, but I know it has to equal 0, so I'm going to subtract 18 first, and I get 2x squared plus 9x minus 18 equals 0. Then I can start talking. I have a equals 2, b equals 9, c equals negative 18. So I have negative b, so negative 9 plus or minus the square root of b squared, so 81 minus 4 times 2 times negative 18, all over 2 times a, which is 2. So I have negative 9 plus or minus. Now I'm going to use my calculator. I have 4 times 2 times negative 18. And I have 81 minus a negative 180 or 144. So I'm actually going to just take 81 plus 144 because it was minus a negative all over 4. Now that gives me negative 9 plus or minus the square root of 225 over 4. The square root of 225 is just 15, so I have negative 9 plus 15 over 4 or negative 9 minus 15 over 4. So I get 6 over 4, which is 3 halves, or negative 24 over 4, which is negative 6. So those are my possible solutions. Okay, let's try the next one. It already equals 0, so I have a equals 3, b equals 5, c equals negative 12. So I get negative b, so negative 5 plus or minus the square root. B squared is 25 minus 4 times 3 times negative 12 over 2 times 3 gives me negative 5 plus or minus 25. Now 4 times 3 gives me 12, times the negative 12 gives me a negative 144. When I subtract a negative 144, it's the same thing as adding 144. And I get over 6. So I get negative 5 plus or minus the square root of 169 over 6. The square root of 169 is 13, so I get negative 5 plus 13 over 6, or negative 5 minus 13 over 6. Negative 5 plus 13 gives me 8 over 6, which is the same thing as 4/3, or negative 18 over 6, which is just negative 3. And those are my two possible solutions. Turn to the next page. I want you to go ahead and try these 3 on your own. Be very careful, make sure you plug in the right numbers for A, B, and C, and then come back to double check your answers. First thing I do for 4 is subtract the 25. I get 10x squared minus 5x minus 25 equals 0. A equals 10, B equals negative 5, C equals negative 25. So I get negative b, which gives me positive 5 plus or minus the square root of b squared, so 25, minus 4 times 10 times negative 25 over 2 times 10. So I get 5 plus or minus the square root of 25. Now I have 4 times 10 times 25, which gives me 1,000, so plus 1,000, because it's minus a negative, over 20. So I have 5 plus or minus the square root of 1,025 over 20. Now, this one does not have a perfect square root, but I can deal with that. I can say this is the same thing as 5 plus the square root of 1,025 over 20, or 5 minus the square root of 1,025 over 20. Now, I could rationalize this and leave this as square roots and a fraction, but I'm going to use my calculator and just type it in. So I'm going to say 5 plus the square root of 1,025, and I get 37.0156, and then divide by 20, and I get 1.85, we're going to say approximately equal to since we're not going to write the whole decimal out. Or 5 minus the square root of 1025 divided by 20 gives me approximately equal to negative 1.35. So those are my two approximate solutions. Okay, this next one is already equal to 0, so A equals 4, B equals negative 24, and C equals 35. X equals negative 24, so positive 24 plus or minus the square root. 24 squared is 576 minus 4 times 35, okay, over 2 times 4. So I get 24 plus or minus, now 576, and then I have 4 times 35, which gives me 560. So 576 minus 560 gives me 16, so the square root of 16 over 8. So now I have 24 plus 4 over 8, or 24 minus 4 over 8. 24 plus 4 gives me 28 over 8, which can be reduced to, divide both by 4, so I get 7 halves, or 20 over 8, which gives me, divide each of them by 4, 5 halves. And those are my two possible solutions. Okay, let's do the next one. Already equal to 0, so A equals 3, B equals negative 2, C equals negative 9. So I get negative 2, which is positive 2, plus or minus the square root of 4 minus 4 times 3 times negative 9 over 2 times 3. So I get 2 plus or minus 4. Now I get 4 times 3 times negative 9 gives me negative 108. Now I'm subtracting that, so it actually becomes plus 108 all over 6. So I get 2 plus or minus the square root of 112 over 6. So I'm going to say 2 plus the square root of 112 over 6, or 2 minus the square root of 112 over 6. Now let's try that in our calculator. So 2 plus the square root of 112 gives me 12.58 and so on, divided by 6. So I get an approximate answer of 2.10. Now it becomes 10 because it's actually 0.097, but if I round that 9, it becomes a 10, so you have to leave that 0 behind there. Or 2 minus the square root of 112 divided by 6 gives me an approximate answer of negative 1.43. Those are my two approximate solutions. We're going to talk about one more thing, and it's called the discriminant. Now, the discriminant is just the expression under the radical sign in the quadratic formula. A radical sign is the square root symbol. Okay? So you can use that to decide how many real solutions you should get. Now, to remember from graphing, you can either get 1, 2, or none. That applies for all quadratic equations, so when you're using the quadratic formula, you can also decide how many answers you should get. Now let's use these examples. I've already written them in. So I have x squared plus 2x plus 5 equals 0. X squared plus 10x plus 25 equals 0. 2x squared minus 7x plus 2 equals 0. Those are the three different equations that we're going to use. Now the discriminant is the number underneath of the radical sign. Now remember that the equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When we're talking about the discriminant, we are only concerned with the numbers underneath of the square root symbol. So b squared minus 4ac is what we're worried about. Okay, so b is 2, so I have 2 squared, or 4, minus 4 times 1 times 5. So I have 4 minus 20, which gives me a negative 16. But remember that this goes underneath of the square root sign, and we cannot have a negative number under the square root sign. So it's negative. And when I graph that, it will have 0 solutions, which means its graph doesn't ever touch the x-axis. Now, the reason it's 0 is because you cannot have a negative number under the square root sign, so we know it never works. Okay, let's try the next one. So I have b squared, which is 10 squared, so 100, minus 4 times 1 times 25. So I get 100 minus 100. Now the square root of 0 is just, 100 minus 100 is 0. So I get 0 as a possible discriminant. And if that happens, you get 1, because that means it touches it one time. So if you get negative under the square root sign, it's 0. If you get 0 under the square root sign, you should have one answer. And then we're going to talk about the next example. We could have b squared, so 49, minus 4 times 2 times 2. So I get 49 minus 16 gives me 33. Now this one is positive, so you will have 2 real solutions. Now these graphs are not accurate for what these ones look like, but that's what you would get if you get a negative one. It will never touch. If you get 0, it will touch once, and if you get positive, it will touch twice. That's the end of your notes. Let me know if you have any questions.